All right. So the next thing I want to talk about. So any questions about that? Any question? Should have not started a new topic. We're gonna have, but please don't let that be a disincentive to ask a question from there. All right. Great. All right, so the next thing that I want to talk about are joins. And again, these are kind of tools in the toolbox for us, right? So we've learned about groups. We've learned about pivots, to do all possible groupings of two categorical columns. And so the join is operation. So the problem that the join is trying to solve, and this is a problem that pops up time and time again, is that the data you want is very often not conveniently in a single table. More often than not, the data that you want is actually going to be scattered in one or more tables, okay? And so the join, kind of, you get the sense of it from the name, the join is an operation that allows us to combine data from two different tables and join them together in a single table. And so I think the best way to kind of explain this is actually to see an example here. And so let's start with a fairly simple table to so we can kind of see all the combinations of everything. And so we have a table here. We have a table of drinks. And so we have particular drinks and the cafe that serves them, and then the price. Okay, so that is our drinks table from there. And then we have a different table, and this table is a table of the discounts we have. And so these are coupons that you have, and the coupon is for how much off at a particular location. Okay, so different companies, different cafes are running different promotions, and sometimes there could be multiple promotions going on even from the same company, right? Think of them as like clipping coupons in your flyer, right? So right now, T1 is offering 2 coupons, like 25% off or 5% off, and then this other place has 50% off coupon. And so we very often would like to think about looking at the data kind of all together. And the key with the join, and if you have two completely independent tables, I don't know that there's much value in joining them. But here, notice that in this one table here, we have a cafe. We have the cafe. And in this other discount, we also have, even though it's called the location, it is the actual cafe. And notice these, you can think of these as categorical columns. They line up, right? The cafe and the location have the same categories from there. And that's going to be the key to the join. That you're going to want to join, whenever you do a join, there has to be a column that is similar between the two tables. There has to be a categorical column. They don't have to have the same column name, but they have to have the same categories. Otherwise, the operation doesn't kind of it doesn't make sense. So let's look at the join here, okay? And we're going to break down exactly what's going on. And so a join is a method on a table. And so we're going to do a join on the drinks table. Okay. And so then what we're going to do here is, and we'll break this down, but we're going to join. So the first argument is going to be a column. It's going to be the cafe column from the drinks table, right? So this is going to be the first argument is going to be the label, a column label from the first table. Okay. And then the second argument is going to be the table you want to join with. Okay, so the first table, drinks, is implicit because we're calling the join method on the drinks table. So that's where the first table comes from. It comes from the method call itself. The second table, the thing we want to join the first table with, is specified here. So this is the discounts is going to be a table. It's going to be a table. And then the last argument to the join is going to be the column that we're going to join on the second table. Okay, So from a practical point, the cafe is a label, a column label from the first table. The location is a label from the second. And so what it's going to do is it's going to kind of go back and kind of do some matchmaking, okay? It's going to do matchmaking, and it's going to find all combinations. It's going to find all combinations where you have matching locations and cafes, okay? And it's going to combine the coupon column with the drink, cafe, and price column with the other table. And so let's just actually see. So this is the result of the join down here, okay? And so let's see how this works. So we're going to match the rows in this table. We're going to look for all of the rows from using values in this column, okay? So we're going to look at all the rows. We're going to look at all the rows from the cafe column. So T1, Nepheli, and Aves, all of these cafes. And then we're going to match them to any locations in the second column, okay? So that's how that works. So let's look at let's do one. And so the resulting table, and so it creates a brand new table, the result of the join. The join is going to have columns from both tables, okay? It is going to have columns from both tables. Notice the location, it's going to have all of the columns except for the one that you used, the column label that you used in the second table, because that is going to be matched with the cafe. So notice you have the cafe, but you don't have the location in the second column because it's going to be matched as being the same as the cafe column, okay? So you won't have the location, but you'll have the coupon. And if the second table had multiple columns in it, you would get all of them except for the one specified up here from there, okay? So you're gonna get the columns from both tables. And then, so how does it do the matching? Well, here what it does is it basically goes through every row in the drinks table. It's going to go through every row, and here are all the values from this particular row. And then it's going to go look, is there any rows that match? And in this case, we have a match here. So we're matching cafe Nepheli to location Nepheli. Here we have a match, and we're going to join those two rows together in this row down here. Notice we have Nepheli and latte, and the price, the cafe, the drink, and the price from the first table matched, joined with the coupon from the second table from there, okay? And that's how that works, right? And so let's look at an example. I don't have this highlighted from here, but let's look at an example from the milk tea. Here, okay? So here we're going to match, and we're going to look at T1. We're going to T1, and we're going to see, in this case, we have two matches. We have this one right here, the first row, and so that's going to be our first match, and we're going to see this down here. We're going to see this match right here, the T1, the milk tea, and the 4 come from there, and we're going to combine it with this coupon here, the 25%, right? So that is the first match we've matched. But then what it's doing is for every row in the first table, it is going to scan every row in the second table. So we had our first match with the T1 here, but then it's going to continue scanning. It's going to continue trying to match T1 from the first table, from this first row, and then it's going to get another match down here at the last row of the second table. And again, the result is going to be, we're going to take all of the values from that first row, T1, milk tea, and 4, and then we're going to combine it with the coupon from the row from the second table, okay? And it's kind of a nice little perk. The join will actually sort the table on your joining label as well, right? So it's going to show you all of the Nephelis together, followed by all the T1s, and then all of the other locations, right? And so notice what didn't appear. Abe's didn't appear in our second table. Why is that? Well, because there wasn't a match with the second table. So when it went through, it was looking for Abe's when it was comparing this last row, this espresso row, it was going through searching each row in the second table, looking for a match. It didn't get one, so it doesn't make it over from there. Okay, and so that's kind of the mechanics of that from there. And in essence, what we've done is we've pulled in the data, the coupon data, from this other completely separate table, matching on a common column, the location from there. Okay, let's see a demo of that. Let's take a look at that from here. Okay, and so here is the table, the drinks table that we had before. And so here I'm just hard coding. I'm just creating the table straight from scratch. It's small enough to do that. And so there's our drink table, just like in the example that we had before. And now we're just going to create the discount table where we're just making an array of our discounts, 25, 55, and then here's our location, right? So this is just a straight application of creating a new table with the with columns method. And so there's our discount there. And then there's our join from there. Again, the thing to remember is that we're calling join on a particular table. This cafe needs to match one of the columns in our original table, right? There's our cafe. And then this is the second table. This is the actual name of an actual table. And this is a column in the second table from there. Okay. And so there's our combined table from there. Okay. So why is that powerful? So now that we have this combined table, we can start doing computations. We can start doing computations on this table. And so, for example, we have the coupon off here, which is good, but really the thing that we probably care about is which place has the cheapest, espresso, or which place has the cheapest milk tea when we take the coupons into consideration, right? So a place might have more expensive drinks, but if it has a bigger coupon, then we'll want to go there. And so that's what we're doing down here. So we're going to basically we're going to create a new column, right? We're going to take our combined table and we're going to add a column with it, and we're going to add a discounted price. We're going to add the discounted price, and we're going to do this computation. We're going to take the price column. We're going to take the price column and then basically take our coupon off, subtract 1 from that, and divide by 100. And that is, right, so what we're doing down here, right? So if you look at the 25% off coupon, well, that's the equivalent of taking the current price and multiplying it by 0.75, right? 25% off means you're going to get it for 75% of its current price. So that's what we're doing here. We're taking the 1 and subtracting it from the coupon off. That gives us the percentage. That gives us the percent of the cost, and then dividing it by 100 to get the 7, like for example for this one, the 75 to 0.75, and then multiplying it by the price, and then that gives us the new table for us. Oops, I'm going to run that from there. Okay, so that's the discounted price, right? So from there. So that's an example of join. And the reason why you want to use join is where you have data in a different table that is related to your first table in some manner, right? If the tables weren't related, the join doesn't work, because there needs to be a categorical column in both tables that match, that have the same categories, because it's physically doing that matching for us. But you'll see this time and time again, especially when you start kind of looking at your own data in the wild. We in this class, certainly in the first part of the class, we have carefully constructed tables for you that have kind of the data you need. But when you go out into the real world, you're going to find that, oh, okay, here's like 3 of the things I need, but then this other table has this other population data. And how do you combine them in there? instead of manually editing a CSV file. And that is no fun, especially if you have hundreds of thousands of lines, or even just tens, even if it's just thousands of lines. Let's have the computer do that for us. And so the join allows us to bring that data together. Okay, all right, I'm going to ask questions first now before I pause. The professor can learn. Any questions on the join? You will definitely, we will get lots of practice doing joins. So we will see examples of how to apply that. All right, fantastic. All right, let me stop this. Next topic is a short one, but can be very useful, especially for our final projects. So the last thing I want to talk about, the next thing I want to talk about, screen share. Next thing I want to talk about is the mapping function. And this is just short and sweet. There's a couple of methods. If you give it a table with longitudes, if you feed it a table with longitudes and latitudes, it will plot very nice maps for you with literally like one line of code. Due to the power of encapsulation and libraries, right? There's a bunch of libraries doing all the heavy lifting for us. But we can create a special type of, at least in the data science package world, a special type of table, a map table. And all that means is that it's just a table that has rows of latitude and longitudes, okay? And we can generate a map of markers. And so on this particular table, the table constructed of latitude and longitudes, we can call two methods. We can call the map table method on two different objects. And that object is either going to be a marker or a circle. Really, it just, the marker basically looks like a little kind of a Google teardrop thing, kind of like the little marker. And the circle is just a circle from there, okay? And so you're gonna give a table, and then the other arguments, so you're gonna give latitudes, longitudes, and then labels, and then colors and sizes, okay? And then these parameters, and I'll show you an example in a second, will apply to all of the features. So you can basically set like the color to blue and the size of either the marker or the circle. So this is something that's easier shown from there. All right, so here's our data science. And so I just pulled a random, I wanted something local for us to see. So I just found this Hudson River Valley Greenway Water Trail designated site. So it's a list of sites of various things along the Hudson River from there. And so if we read this table, hold on, I just got to reconnect. Okay, and if we read this table, it just has like different parks, the community it is, the county, and then the important thing is it has latitude and longitude, right? That's the important thing. The data that you want has to have a latitude and longitude associated with it. And these are a bunch of things, a bunch of parks, boat launches all along the Hudson River. Okay, and so again, so what we're going to do here is we're going to basically take our places table, and we're going to select the latitude column and the longitude column, and then the site column from there. Okay. And then it's just going to make a map of us, again, because the first column is going to be interpreted as latitude. The second column specified in is going to be specified as longitude, and the site is just a name for the marker. But for some reason, it's not being displayed properly. The sites. I need to figure out why that is. I couldn't figure it out last night, but basically what you get with literally one line of code is this kind of really funky map. And then and these are the markers, right? They look like the little Google markers, and you can scroll around with this map. And then here is there's Kingston. So here's Poughkeepsie, and then here is the kind of the various things from there. And if you click on it, you're supposed to get the site name from there. And I will hopefully figure out where the bug is. I actually reinstalled the data science package, and then I broke it for everyone like at midnight last night. And none of you were working at midnight, or if you did, you didn't complain that the data science package was broken for about a half hour. But anyway, hopefully we'll get to the bottom of that. But then there's just little markers there from there. And so if you ever have kind of geographic data, this is really pretty amazing that we can kind of do that with one line of code for that. And you can scroll out and zoom in, and you can see, wow, there's like a ton of stuff all along the Hudson River from there. Okay, so that's the marker. And we can do the exact same thing. It works exactly the same way as the marker, but we can have little circles instead of little, I don't know, little arrow type things from there. And then, so what I've done here is I've just selected all of the things in Dutchess County, right? Poughkeepsie is in Dutchess County, so we live in Dutchess County. So here are all the things. So instead of having all the different items there, I just did where county equals Dutchess. So if you look back at our original table, it's just selecting for Dutchess. And fun little thing, I was getting this demo ready last night, and when I selected Dutchess, nothing appeared. Nothing appeared. I got an empty table. And then I was like, what's going on? And then I was like, oh, am I doing this wrong? No, because then I tried like Saratoga, and Saratoga worked. But when I did a select on Dutchess, and again, I just grabbed a random data set off of, I literally did a Google search, Dutchess County CSV file. And I think this was like the first thing that popped up. And so it wasn't working for Dutchess. It was working for the other counties. And so I'm like, all right, what? So I looked at the raw CSV file, and it turns out that the CSV file had Dutchess with a space after the Dutchess, a space after the S. And so it wasn't matching Dutchess. It was looking for Dutchess with a space after that. And so if I did the search with the space after it, and everything worked fine, but I ended up just editing the CSV file. So, to fix it, to take out that. So when you deal with data in the real world, data is most often not clean for that. And so whenever you have the opportunity to do some cross-validation, testing out the data, these things just pop up all the time. And as you kind of get more into your career as budding data scientist, you will find a disappointingly large amount of time is actually spent cleaning and validating the data from there. So that's just something to kind of be aware of when we do things in the wild. And there's really not too much more to say about that. And then again, so the other thing is that aside from that, you can set the color. I've set it to blue, and you can set the size of the point of the marker as well, right? You can make it a little smaller. And then those were slightly smaller from there, and you can make them different colors as well. So for your final projects, just remember this tool in the toolbox for kind of visualizing geographic data from there. All right. Any questions about that? And there's no magic there. It's just knowing that exists and feeding the table, feeding the right columns from a table, right? And as you saw, we didn't have to make a specific table. You can use any table as long as it has a latitude and a longitude column associated with it, and then you just give the proper labels from that table to the first parts of the argument there, either to the marker or the circle object from there. And again, it's the table method from there. Okay, I think that's all I want to say. That's all I want to say about that. So.